Alright, so we now know basically what systems of equations are, and that's just when we have more than one equation. And we need that because if our equations are written in more than one variable, we need the combination of the two equations to be able to help us to solve for both of those variables. We're going to start now learning different methods to solve those multi-variable and multiple equation systems. Okay, the method today is substitution, and these two sections are both about substitution. So there's really not any difference between section 2 and 3. 2 is more of an intro and 3 is more of an application, but we'll see them both. Kind of the idea behind solving with substitution is we're going to be plugging in or substituting a known value, maybe it's an expression, into another equation until both values, like your x and y or a and b, are both found. Okay, so let's try one system that's already written for us. We don't have to do the writing, it's just there for us. Okay, so we want to find this known value. Okay, and known value means that it's already solved for. Okay, and I see that y is solved for in both of them. Okay, and if y is equal to this and y is also equal to this, what do we know about these two pieces? We know that they are equal. So think of it as substituting this value of y in for this y, or vice versa. Okay, and now it's just a nice equation written in one variable that you know how to solve. So x equals 3. Okay, remember when we were solving systems, however, if it just says solve the system, we need both values. Okay, so I know x. Now how am I going to go ahead and solve y? Well, since I know x, I'm going to substitute x in for the x in my equation. Ooh, I think this is 4. Sorry, that's not 3. That's 4. I divided wrong. X is 4. Okay, so then 20 minus 25 is negative 5. Does it matter which one I plug into? Absolutely not, as long as you have the right number. So negative 8 times 4 plus 27, negative 32 plus 27, still negative 5. So there's our solution solved by substitution. Okay, so a lot quicker than graphing, really. The rest of these not only practice substitution, but also writing the equations. Okay, a taxi ride in Buford costs $1.50 plus 20 cents for each tenth of a mile. Spotswood, taxi rides cost 90 cents plus 25 cents for each tenth of a mile traveled. For what distance do rides cost the same? So it's definitely easy to pick out the two equations. Here's one situation, here's the other. Okay. Something that's the same is this tenth of a mile traveled. So I'm going to call this tenth of a mile my x, or whatever, so that I have that multiplicative factor times my mileage. Okay, so the cost in Buford is $1.50 for sure, then 20 cents for each tenth of a mile. The cost in Spotswood is 90 cents plus 25 cents for each mile. Hopefully you can kind of see the parallels from this to this up here. If these are both talking about a cost, and we want to know when their costs are the same, let's just set their costs equal to one another. Alright, so then let's just do the math. Okay, so that's x equals 12. The question asks, for what distance do rides cost the same? Up here, we're just solving for x and y. There was no question. Here, for what distance, okay? Well, x, remember, is 1/10 of a mile. So I want 12 of those 1/10 of a miles. So if you multiply 12 by 0.1, that tells us that at 1.2 miles, our rides cost the same. And that's all we needed. We don't have to find the cost at that time. You could, but this is the question that was being asked. Okay? Some Boy Scouts and some Girl Scouts sponsored a car wash that made $109. There were twice as many girls as boys working, so a decision was made to give the girls twice as much money. How much did each group receive? Okay, so we're going to call B the amount that the boys made, and the girls the amount that the girls made. Okay, so if I add the boys and the girls' money, that's going to give us our total. That one was easy. Okay, there were twice as many girls as boys working. Twice as many girls as boys working. So how would we write that equation using the B and the G? Because again, that's going back to how much money. So the girls received twice the amount that the boys got. Okay, now going back up to our general rule, we want to plug in a known value, the one that's solved for. So if I look down here, G is solved for. So I'm going to plug that value into the other one, the other equation, so that I get rid of my two variables. Sorry, my lights keep going off in my room. Alright, so do you see that? I took the solved for variable, plugged its value in, and now I have an equation written in one variable. And it looks like the boys made 36.33. Okay, so now you could go and plug this B back in here or in here, and it'll tell me how much the girls received, okay, because we want how much each group received. Since I know the girls received twice as much, I'm just going to double that. And the girls received 72.67. Okay. Two lines have equations 3x plus 2y equals 10 and y equals 4x plus 1. Where do they intersect? Okay, so thinking back to your graphing assignment from last week, we know they intersect at the one point that satisfies both of them. Okay, we're not going to graph it, we're going to use substitution. Okay, I'm going to go again back and try to find a known value or something that's solved for, and in this case, y right here is solved for. So what should I do with the value of y? I'm going to plug it in for this y in the other equation so that I don't have two variables. So I'm just copying this equation, but instead of writing y, I'm going to write the value that I know y holds. Okay, so this, everything is the same, except instead of y, I'm writing y's value. Okay, look. everything is x's. Just a little bit of distributive property. That looks like, see, 11x equals 8, divide by 11. X equals 8/11. Okay, so again, that's my x value, and I want to know where these two lines are intersecting. Yeah, it's maybe an ugly point, but that's fine. Now I need y. So how will I find y? Again, you can take this x value and you can put it here or here. You will get the same answer. I don't think either one of them looks particularly more easy, but since y is already solved for, I think I'm going to use this one. So y equals 4, instead of writing x, I'm going to put the value. (32/11 plus 1). Let's make that 11/11, because that's the same as 1. So that gives me y equals 43/11. And there's your solution. If you wanted to graph it, go ahead, look at Desmos, graph it, see where they intersect, and that should be the point where they intersect. Okay, one last story problem that we have to write an equation for. This is from an 1181 algebra text. I think I have that date right. So the problem is still good, but the information is clearly outdated. A farmer purchased 100 acres of land for $2,450. For part of it, he paid $20 an acre and $30 an acre for the rest of it. How many acres were in each part? Okay, since it's asking how many acres, okay, I'm going to call x and y the number of acres in both parts. Okay, well, I know one part plus the other part gives me a total of 100 acres. So there's one equation. Now I have information about cost, or the price, for my other equation. He paid $20 an acre for some of it, and $30 an acre for the rest of it, for a total of $2,450. Okay, you're probably saying now, if we want to do substitution, we need something solved for. And you're right, but look at this equation. It would be so easy to solve for either x or y, so we're going to do that first. I'm just going to subtract y to the other side. And now I have something solved for, okay? So I'm going to plug in the value of x here in for my variable there. So I'm going to have 20. I'm not going to write x, I'm going to write 100 minus y plus 30y equals 2450. Okay, so again, that's this equation written all with y's because I wrote the value of x in terms of y. So we have 2,000 minus 20y plus 30y equals 2,450. We subtract 2,000. Negative 20y and 30y is 10y. So y equals 45. So this is telling me that I have 45 acres at the $30 price. Okay. And then think about it. I have 45 acres of this kind, and I need 100 acres. So what's x going to be? Okay, you can plug it in if you don't see it. That's fine. So X is 55. So we have 55 acres at the $20 cost. Okay? Definitely the battle sometimes is writing the equation, but that's why I've been encouraging you not to try to guess and check all year long, that eventually we're going to have to write some equations. Okay?